Hi guys, back again with another honors video. So this is going to be coming from 2.3. So when we're going through 2.3, we only touch on synthetic division in order to factor things, find if something was a zero, and so on. So we only touch on synthetic division this year. But synthetic division is only helpful to a point. So if we have a larger degree divisor, we cannot use synthetic division. That then has to roll over to using long division of polynomials in order to find factors, to find zeros, and so on. So in this honors topic video, we are simply going to talk about using long division to divide out polynomials for us, like a whole bunch of different reasons, mostly being everything we learned in 2.3. That we need them in order to find factors, we need them in order to find x-intercepts and zeros, and things like that. So when we're going through this long division, it's going to seem like we're kind of taking it slow maybe because you probably don't remember how to do long division. You've learned it before, but there's little things we need to make sure that you remember how to do. We're just going to do one problem, and that's it, because I'm quite sure after one, like, you'll be able to get the hang of it and start some of your own. So this is going to be the only other video coming from chapter 2 for honors topic videos. So two things, they both are a little bit more time consuming though, so I don't want to add too many more onto the test. They'll likely both be worth either 8, 9, or 10 points when it comes to the test. So we want to divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. So this is something that we could do with synthetic division. Because of the fact that this is a lower degree function that we're dividing by, you could use synthetic division. I just want to show it with a little bit more of a slower example because I'm not going to get too crazy with these with you guys. It's more of the process that you know how to do long division versus know how to do like the hardest of the long divisions. But if this was something like x squared plus 3, that would be something that we would have to use long division for if that was something that we were dividing by. If you remember, long division is kind of like set up in the opposite way of synthetic. So we have this still big backwards or half of a rectangle, but it's flipped the other direction. What goes on the outside is still what we're dividing by, but it's the entire thing. So if you remember with synthetic, we only grab just the numerical portion of it. In this case, we take that whole portion. So the other thing, we again have to check for zero placeholders. So we have to know, do we go from a cubed all the way down to our last constant without skipping a term? In this case, we go from a cube to a square to just a single x to a constant. So there aren't any zero placeholders that need to be put in. So we can go ahead and write that entire function, right? Difference of synthetic division to long division. The entire function comes down, not just the coefficients. So what happens here is we have to figure out what number is going to go on top. So I have to be able to completely cancel out a 6x squared. So I say, okay, x multiplied by what number will give me 6x cubed. So this is one way to think about it. We'll do it this way first. So x times 6x squared is going to give me 6x cubed. Okay, this is just something that I can know, and I can go ahead and check. X times 6x squared gives me 6x cubed. Another way for people that maybe if this doesn't come as easily to them, you can bring this term over to the side and divide it by that first term. That would give me 6x squared. So that's what would go, that is not a 6. That's what would go up top. Two different ways of doing it. You can take that first term and divide it to see what number goes up top, or you can say, what number do I have to multiply by this number to get this number? Either way of thinking about it is the same and probably just as easy. So now that I've found out that number, I have to now multiply each of these terms by this top number. So x times 6x squared is, ooh, that doesn't work, is in fact 6x cubed. You can't see that either. Let's try my whole rainbow of markers. That's better. So then now negative 2 times 6x squared is negative 12x squared. Oh, you still can't see that. I'll just write it all in black. So there was this little like chant saying, I guess you would say, whenever you first learned how to do long division that they would have taught you. And that saying is draw the line, change the sign. So I need to draw this line because now I'm subtracting my top from my bottom. So I'm changing the sign, which is a really important step. We say change the sign because since we're subtracting everything in this bottom row, a lot of people forget and only apply this subtraction to my first term. This subtraction applies to both terms. So I'm changing the sign of my 6x to a negative 6x, my negative 12x to a positive 12x. Now I can basically add straight down. 6x cubed, negative and positive versions of each other. If these aren't canceling out, you did something wrong. These should not. Negative 19x squared plus 12x squared, that's negative 7x squared. I bring down my next term. I'm gonna bring down all the terms actually. And now I keep going. So I do this process over again, where I say, what number will multiply by x to give me negative 7x squared? If I multiply this by a negative 7x, that will do just that for me. Again, you could have brought this over to the side and said negative 7x squared divided by x, right? I don't know why I did that way. That gives me negative 7x. So that's how you're thinking about this. That's more than okay. Now I go back through and I do the multiplication. X times negative 7x is negative 7x squared. Negative 2 times negative 7x is positive 14x. Draw the line, change the sign. So in some of these, you're going to have to almost erase what you already put. So I had to change that subtract. Oh, you can't see. I had to change this addition to subtraction here, right? This was addition, but I changed both of these signs here. Now I can add straight down. These cancel out. 16x plus negative 14x is positive 2x. Bring down my negative 4. Continue the process again. X times what gives me 2x? That answer is positive 2. Again, thinking about it in the division way, this would be 2x divided by x. That is just simply positive 2. So x times 2 is positive 2x. Negative 2 times positive 2 is negative 4. I draw the line, I go and I change the sign. These cancel out, which that first term should always cancel out. In this case, I actually cancel both of these down to 0. This is not a common thing. What this means is exactly what synthetic division meant. This was a factor. Since my remainder was 0, x minus 2 was a factor of this function, okay? So this is just simply the long division process. I would have written my remainder just like I would have if I had one when I showed you in synthetic division. One other kind of a cool important thing to say, just because this problem works out this way, since I have a remainder of 0, this was a factor. So this whole function ended up actually factoring to x minus 2 multiplied by everything on top. So 6x squared minus 7x plus 2. So this is the factored out version of this function. And obviously, it's not factored out completely, but I could factor that more using the AC method. But I'm at least halfway there. And I don't know how to start something that looks like this to factor it. So this helps me in order to get that first part factored out. But again, this is long division. I will post some problems that you can try that will help you in practicing some long division. But that's it.